Let's take a look at our first section in chapter 2. Okay, the section is 2.1. Okay, we'll do half today, half tomorrow. And in this section, basically what we're going to study is angles. Okay, we'll define what an angle is, how we measure it. Okay, there's two different units we can use, and how we convert between the two units. All right, so we'll start out by defining what an angle is. But to define that, we have to define a couple things that make up an angle. Okay, one of those things is a ray. Okay, so a ray is basically a portion of a line that has a starting point. We call a vertex. And it extends in one dimension forever. Okay, so you can think of a ray visually as kind of like turning on a flashlight. Okay, you turn on a flashlight, the light goes in one direction, doesn't go in the other direction. Okay, that's a ray. Okay, and when we take two rays and put them together, that's how we make an angle. Okay, but we can't just take two rays and just stick them together any way we want. We have to put the two rays together so they have the same starting point. Okay, they have the same vertex. So take two rays, put them together so they have a common vertex. Now you just made an angle. Okay, so this is one way to think about an angle. Okay, when we draw shapes, okay, we also think of angles in that way too. Okay, like a triangle. Okay, we look at that shape and we've got three angles. Well, in a triangle, really, you just have a bunch of segments. Okay, you don't have rays. Okay, but if we're just drawing an angle by itself, usually you draw it with two rays, just like this. That's usually how you sketch an angle by itself. Later on, we'll talk more about angles inside a triangle and other shapes, but mostly triangles. Okay, when you sketch an angle like this, you've got two sides to it. Okay, one side is called the initial side, and the other side is the terminal side. Okay, in the diagram up above, this is the initial. And the other side is the terminal side. Okay, and how do you really tell which side is which? Okay, well, if you start at one side, okay, and you go in a counterclockwise direction, the side that you end up at, that's the terminal side. Okay, wherever you end, that's the terminal. Wherever you started from, that's the initial. Okay, I have another picture of an angle. Basically the same diagram. Okay, any questions on that so far? What an angle is, the initial terminal side, vertex, any of that? Okay. So there's different ways that we can measure angles. Okay? Generally, we either measure them in a clockwise direction or counterclockwise. Okay. If you go from the initial side to the terminal side, and you go counterclockwise, just the way I have the arrow drawn here, that's a positive angle. Okay, so if you go counterclockwise, that's positive. And what I'll probably do in the future, just to save out writing the words counterclockwise, I'll use the abbreviation CCW. So this is counterclockwise. Okay, what do you think would happen if you measure an angle in the clockwise direction? What kind of angle do you think that would be? Yeah, it would be negative. Okay, so if you measure it the other way, clockwise, that's negative. Okay, abbreviation I'll use CW for clockwise. And that's that way. Okay, and what I'll do is I'll bring up a program that lets me draw angles. Okay, and I'll sketch some counterclockwise, and then I'll do some clockwise, and you'll see the difference on how the program measures the angle, whether it's positive or negative. Okay, so let's start with the positive. Okay, so if I go counterclockwise, I'm going to get a positive angle. So basically what I have is a circle. On this circle, I cannot move the initial side. I can only move the terminal side. All right, so as I move the terminal side in a counterclockwise direction, you can see my angle is positive. Okay, anybody know what the units are on this top number? Yeah, it's measuring in degrees. Okay, that's the little circle. We haven't talked about the bottom number. We're going to later today. But anybody know what the bottom number is? Radians. Very good. Okay. Now, what would happen if I made a full revolution, brought the initial side all the way around so it's on top of the terminal? How many degrees would that be?
360.
360. Okay, so that's an important idea to keep in mind. If we do a full revolution, that's 360. All right. So now if we start going back the other way, what kind of angle should I get if I start going clockwise?
Negative.
Yeah, I'm going to get a negative. Right? Now it's measuring the angle the other way. Right? The initial side is still the horizontal, and the terminal side is the one on the angle, slant. Okay? All right. Right, so there's a lot of different ways we can sketch an angle, and generally the way we like to sketch it is what's called standard position. Okay, to draw an angle in standard position, two things have to happen. Okay, one, the vertex is at the origin. Okay, so if you have an xy axis, make sure you put the vertex of the angle right at the origin. And second thing we want to do, make sure the initial side is on the positive x-axis. Both of those things have to happen for an angle to be in standard position. Okay, there's a picture of an angle in standard position. Vertex is right at the origin. The initial side is right on the positive x-axis. And if you draw it that way, then it takes all the guesswork out of which side is initial, which side is terminal. The initial side is always going to be on the positive x-axis. Okay, Jamie, if I take this angle and move it like that, is that still standard position? Right. Vertex isn't at the origin. Okay, the initial side is still where it needs to be, but the vertex has to be at the origin. Okay, let's say I did something like this. Okay, Brianna, is that in standard position? Nope, what's wrong with it now?
The initial isn't on the x-axis.
Yeah, the initial side is not on the positive x-axis. Vertex is at the origin, but that's only half of it. Okay, so any questions how to sketch an angle in standard position? All right, it's pretty straightforward. All right, so that covers the kind of the basics on angles. Yeah.
For
for the negative and positive for the angle, technically can the angle, you can measure it negative and positive, or is it just one way?
You can measure it both ways. Yeah.
Oh, okay.
So, no, that's a good point. So you might, for example, a positive, if I can line it up, positive 90 is the same as a negative 270. Is that what you were getting at?
Yeah.
Yep. There's no difference in where the initial and terminal side line up. It's exactly the same picture.
So when we measure angles, are we going to have to do like both or just one?
Generally, we just want the positive.
Okay.
So a lot of times, if I give you an angle that's negative 270, you would want to convert it to positive 90. Okay, we'll talk about that as we go. You basically just add 360 to it.
Okay.
But that's going to be, I think, next week. All right, so degrees and radians. We already said this fact earlier. I asked somebody what would happen if you went all the way around the circle, brought your initial side all the way around. How many degrees would it be? Okay, and we knew that it was 360. Now, using this fact, in one revolution, there's 360 degrees. That would allow you to convert revolutions to degrees, or degrees to revolutions. Okay, very simply, all you'd have to do is set up a proportion. In one revolution, there's 360 degrees. Let's say I wanted to know how many degrees in 2.5 revolutions. Just put 2.5 revolutions is how many degrees. Okay, and generally, we solve a proportion by doing what?
Cross multiply.
Yeah, you just cross multiply. Okay, and basically here it would just be 360 times 2.5, and that would tell you how many degrees in 2.5 revolutions. Okay, but what we really want is a way to change degrees to radians. I'm not going to really spend a lot of time playing with revolutions. We're going to do more with degrees to radians. So we've got to figure out that. How many radians in a revolution? Or how many radians in 360 degrees? Okay, first thing I'm going to do is just give you kind of a description of what a radian looks like. And then later on, we'll figure out exactly how many degrees are in a radian. Okay, I'm going to start with this picture. Okay, what I've drawn here is a circle. I got an angle inside it. The vertex is right at the center. And I've drawn the rays of the angle out till they hit the edge of the circle. And I've labeled the length of each ray R. What do you think R stands for in a circle?
Radius.
Yeah, it's the radius. Okay. And notice the word radian and radius. They kind of start with the same letters, right? They sound similar, and that's because there's a relationship between them. Right? So I've labeled the length of this ray R, the length of the other ray R, and then I've drawn in one more thing. Okay. One of the rays hits the circle right there. The other one hits right there. And then I drew in this curved segment called an arc. Okay. I drew in the arc between the 2 points where the rays hit the circumference of the circle. So this arc right here, if you were to measure it, okay, I tried to draw it as accurate as I could, but if you were to take a piece of string, measure the length of that arc, then take a piece of string and measure the radius, in this picture I want them to come out the same, okay, the way I tried to sketch it. So the length of this arc is exactly the same as the radius. Any question on that diagram? If you change the size of this angle, that might not always be true. Okay? If you make this angle smaller, that arc is going to get smaller. Okay? It wouldn't be the same size as the radius. If you make the angle bigger, the arc would get bigger. And again, it wouldn't be the same size as the radius. So this is very special when that happens. If that does happen, if the length of the arc is exactly the same as the radius, then what you've done is you just drew a picture of an angle that's exactly 1 radian. So if you measure the arc and you measure the radius and they come out the same, you just drew a picture of an angle that is exactly 1 radian. It still doesn't really help us to convert degrees to radians or vice versa, but it gives us an idea of what a radian would look like to try to sketch it. So the next part, we're going to try to figure out how we can change between radians and degrees. Okay, and I've got to give you a piece of information. Okay, we've got to start with something. So this is what we're going to start with. Okay, it says that an angle's measurement in radians is numerically equal to the length of the corresponding arc on a unit circle. Okay, and if you measure an angle in radians, take that number, and then you measure its arc, okay, like this thing in red, it's going to come out exactly the same as the size of the angle. So in other words, arc size and angle size in radians come out the same, as long as you use this kind of circle. Okay, does anybody know what a unit circle is? It's a circle with a special radius. Anybody know what the radius is? It's a circle with a radius of 1. Okay, so if you sketch a circle on paper with a radius of 1, whatever you want, 1 inch, 1 foot, okay, whatever it is, 1 unit. The size of the angle and the size of the arc will always come out exactly the same. Right, now we can use that fact. Okay, keep in the back of your head that 360 degrees is 1 full revolution. Okay, we'll come back to that. Does anybody know, what do we call the name of an arc that's so big it's not part of the circle, but it's the whole circle? What would be an arc that goes all the way around a circle? Do you think what that's called? What do you call the distance around a circle? The circumference. Yeah, the circumference is basically just an arc. But it's an arc that's so big, it goes all the way around, and it connects where it starts to where it stops. But that's really an arc. Does anybody remember what the formula is to find the circumference of a circle? Or maybe at least, what's a number we usually use with circles? Pi. Okay, so it's got pi in it.
Isn't it like radius times pi or something?
That's another part. So we got,
Square.
yeah, just 2 pi r. There we go. Good. Okay, so that's the circumference of a circle. Okay, and remember what I said. On a unit circle, the size of the angle and the size of the arc are going to be identical. So if we can figure out how big the arc is that goes all the way around the unit circle, that's exactly how many radians go all the way around the unit circle. Those things are equal to each other. Right? So what I want to do is figure out the size of the arc that goes all the way around the circle, and that will tell us exactly how many radians it takes to go all the way around the circle. Okay. What's my radius on a unit circle? 1. So we're going to fill that in. So we get 2 pi times 1. Multiplying by 1, that's not going to change anything. So the circumference of a unit circle is 2 pi. Now, if the circumference is exactly the same as the angle, how many radians is it going to take to go all the way around the circle if it's exactly the same as the circumference? 2 pi. All right? It takes 2 pi radians to go all the way around a circle. 2 pi radians. And you might have seen that on here. When I went all the way around, it says 360 degrees is 2 pi. All right. So it takes 2 pi radians to go all the way around the circle. How many degrees does it take to go all the way around the circle? 360. So these two things are the same. Now we've got a conversion between degrees and radians, which is now going to allow us to change back and forth. Okay, one thing we can do on each side to make this a little simpler, just makes the numbers smaller. Let's divide everything by 2. So in a half circle, okay, or 180 degrees, that's pi radians. Now that's fine for a conversion, but it's kind of confusing. Because when you give someone a conversion, conversions usually have a certain number in them. Anybody think they can tell me what number do conversions usually have that make them easy to use? How about if I wanted to convert between feet and inches? What's the, how would you explain that to someone? In how many feet are how many inches? Oh, Justin?
What do you mean, how many feet are in?
So how many feet to how many inches? If somebody wanted to know what's the conversion?
5 by 12.
Okay, so in how many feet in how many inches?
1 foot, 12 inches.
Yeah, 1 foot, 12 inches. Which, if you're converting inches to feet, you would divide by 12. The other way you multiply. Okay, how about minutes to seconds? What would be how many minutes to how many seconds?
1 minute, 60 seconds.
Yeah, 1 minute, 60 seconds. Okay, both of those have what number in them? 1. So anytime you have a conversion, usually you like to tell it to somebody with the number 1. Okay? Notice we didn't say in 3 feet there's 36 inches. True. But you're giving a harder conversion than necessary. Okay? We try to give the simplest one we can. Let's see if we can simplify that a little bit. What I want to do is, let's get a 1 on the left-hand side. What could I divide each side by that would make a 1 on the left? And divide it by 180. And if I divide each side by 180, I get 1 degree equals pi over 180 radians. Okay, so now this tells you exactly how many radians in 1 degree. If I wanted to know how many radians in 2 degrees, simple. Times 2 times 2. Now in 2 degrees, I could do that calculation out on my calculator. If I wanted to know how many, I don't know, how many radians in 5 degrees? Times 5 times 5. Okay, this pi over 180 is very important. All you have to do is multiply that by whatever you're trying to convert. Okay, so there's 2 steps to change a degree to a radian. Okay, the first step is multiply by pi. And the second step is to divide by 180. Multiply by pi and divide by 180. Okay, and as we start to go through it, when you think of degrees, okay, 180 is the number we're going to think of when we think degrees. Okay, we're going to use that. And when we're dealing with radians, I want you to think of pi when you think radians. So 180, think degrees. Pi, think radians. Okay, that's going to come up in a minute. Okay, any questions on the two steps to change degrees to radians? All right, let's go back to that equation we just had. 180 degrees equals pi radians. What do you think I could do a little bit different but similar to get a conversion the other way? I want to get a conversion that'll get me from radians to degrees. What could I do? Yeah, Tyler?
Divide by pi, multiply by 180.
Yeah. If you divide each side by pi, look what happens. You're going to get 1 radian equals 180 over pi degrees. So if you want to know how many degrees are in a radian, go ahead and divide that out. It's about 50, it's just a little bigger than 57. It's about 57.3. Okay, so notice how similar these are. One of them's pi over 180. The other one's 180 over pi. All right, so to change, let's see if I can fit them both. To change from radians to degrees, this time you multiply by pi. I'm sorry, multiply by 180, divide by pi. And remember, when you see 180, that's the number I want you to think of with degrees. Pi, that's the number I want you to think of with radians. Okay, so it's kind of hard sometimes to remember which one is which because they're so similar. One of them's multiply by pi, one of them's divide by pi. So I'm going to show you how you can remember which one's which. All right. So we're going to convert 60 degrees to radians. Cooper, what's the units I want to end up here with when I'm done?
Pi radians?
Yeah, I want to end up with radians. Yeah. All right, so somehow we want to get rid of degrees. All right, so Tommy, if I get degrees, think of degrees as being in the top of this fraction. Where would it go over here to make it cancel out?
Top.
Bottom. Yeah. So anytime you have a fraction, if you have this something in the top, something in the bottom, same thing, they cancel out. All right, so I have degrees in the top. I want to make it cancel out. I'm going to put it at the bottom. Okay. Now we just have to decide, is it 180 in the bottom or is it pi in the bottom? Well, we've got the degree symbol. What number did I say always think of when you think degrees? Josh?
180.
Good. You're 180. Okay, so 180 goes in the bottom, which means pi goes in the top. You only have two choices for every problem. Pi over 180 or 180 over pi. Okay, so we have degrees in the bottom, degrees in the top. Cancels out. And Hunter, what can I divide both 60 and 180 by to reduce it. What can I divide both 60 and 180 by to reduce that? 3? Even bigger. Think really big.
60.
Yeah, you can divide it by 60. All right, so divide the top by 60 and the bottom by 60. 60 goes into 180, Brandon, how many times?
3.
3. Okay, unless they ask you to round to a decimal, don't worry about it. Okay, just leave it as an exact answer. In the top, I have 1 times pi. Bottom, 1 times 3. And that's it. So that's the answer, pi over 3 radians. Okay. The other thing that's a little weird is we don't label it radians. Okay. Some people like to put this on it at first till they kind of get used to it. But anytime you're working with an angle in trig or pre-cal, basically any class, if it's in radians, you do not have to label it. If it's in degrees, you do. Okay, degrees, you put the little circle. But that's it.
So when you're doing that, do you have to set it up like on paper like that, or can you do that in the calculator? Or no?
Well, you want to make sure it's an exact answer. You don't want a decimal. So if the calculator is going to give you a decimal, then no.
Okay.
We'll do one where we plug it in, though. The last one we do. Yeah. And we'll get a decimal. So generally, they're not going to ask for decimals, though. Yeah, Tyler?
I was going to ask, like, if we could put it in decimal, but you just answered.
Yeah, no decimals for these. Okay, any question on that one? All right, let's try this one. All right, again, we've got 150 degrees. We're going to try to get degrees to cancel out. So Florencia, if we got it in the top, where do we put it to cancel?
At the bottom.
At the bottom. We just put degrees in the bottom. Megan, what number always goes with degrees?
180.
Good, 180. Which leaves what number in the top, Megan? Pi. It's radians. It's understood to be radians. You do not have to write RAD. Okay, so I'm going to divide this out. 30 goes into both. Amber, how many times does 30 go into 150?
5.
Yep, 5. How many times does 30 go into 180?
6.
How many times think about how many times does 3 go into 18?
6.
So this is the same problem with just a 0 on the end. Okay. So our final answer here is going to be 5 times pi over 6. Again, I know it's in radians because I'm talking about an angle, and there's not a degree symbol. Okay, any question on that one?
Why do we convert all this to radians?
Why do we convert to radians? Well, we're going to use some formulas tomorrow that the formula only works if your angle's in radians. Yeah. And besides this class, if you ever take like a calculus or anything, if you have to take more math, everything in calculus is done in radians. It actually makes things easier. It seems a little weird at first. It almost seems like, well, why don't we just use degrees? Well, degrees actually make some things harder in other math classes. So you'll see tomorrow with our formulas what we have to do. All right, try those two on your own. Okay, see if you can convert negative 45, positive 90. Okay, and if you get them, let me just come take a look and see what you got. Okay, so keep in mind, as I said, if an angle's negative, it's going to stay negative. You do the same steps. Multiply by pi, divide by 180. Okay, degrees in the bottom, degrees in the top, cancels out. And these are both divisible by 45. 45 goes into itself once, and it goes into 180 4 times. So you're left with negative pi over 4. Okay, some people put the negative in the top, some people put it in the bottom. It doesn't matter. Generally with a fraction, you just throw it in the top, but that's fine. And the last one, Josh, what did you get for that one?
Oh, I got it. What do I say? Do I say radian on the top part?
Just your final answer, but you could say radians, yeah.
All right, I had pi over radian, 2.
Yeah, pi over 2 radians. That's correct. Okay, so the 2 comes from right here. 90 goes into itself once, goes into 180 twice. 1 times pi is pi, with a 2 in the bottom. Okay, pi over 2 radians. All right, so notice this angle is a little different than the others. Okay, 90, 45, 150, and 60. All those angles are either multiples of 30, like those two, or multiples of 45. Okay, this one's not. Generally, if you have an angle that's not a multiple of 30 or 45, they're going to say round to 2 decimal places. Okay, you're never going to have to guess on a test. Should I round it? Should I not round it? I will tell you. Okay? So we're going to convert this exactly the same way. I have degrees in the top. To cancel it out, put it in the bottom. Always put the degree symbol with the number 180. And then put the pi wherever you didn't put the 180. In this case, the top. Okay, and for this, you just type it in. Okay, it says round it off. When you type it in, make sure you use the pi button. Okay, on the last calculator one we do, I'll show you what happens if you don't. Okay, so we got 107 times pi. Okay, so there's the top. And then divide by 180. So it's about 1.87. What's my unit on that? Radians. Do I need to write it? No. You only label it if it's a degree. So any questions on converting to radians?
Where did you round that?
Where did I round it? I rounded it to the second decimal. Yeah, to 2 decimal places. Okay, on the homework, there'll be a section that says convert to degrees, leave it exact. Then there'll be a section that says convert to degrees, round your answer to 2 places.
Wait, actually, can you do that again? Because I wasn't watching.
Yep.
With the calculator.
Yep, we're going to just type it in just like we see it. 107 times pi.
Okay. I was gonna like cross multiply and then divide.
Oh yeah, just straight across.
Okay.
Yep, straight across. All right, and last thing, how do we convert to degrees? Okay, for the first one, I'll leave the label RAD on it so you can kind of see it, but I'm going to erase it for all the next ones. All right, so we're trying to get degrees. All right, so what we want is radians to disappear. Okay, Corey, where would I put radians to make it cancel out? Top or bottom?
The bottom.
Yeah, it would go on the bottom. Okay, it's in the top of the fraction on the left. I'm going to put it in the bottom on the right. Okay, good job. Okay, and how about Kobe? What number do you always, I said to think of when you think radians? Or do you remember what number to think of always goes with degrees? Yep, 180 always goes with degrees. And what's the only other number we're working with? 180 and pi. Every problem is 180. It's either 180 over pi or pi over 180. George, what's going to cancel out there? What's going to cancel out here? Yep, pi's gone. Anything else?
You can do a 6 and get 1.
Okay, yep, we can reduce 6.
Oh, and the radians cancel out.
6 goes into itself once, 6 goes into 180,
30.
30. And then you started to say something else too.
The radians cancel.
Perfect. Okay. So the only thing you're left with is the degree symbol and the 30. That's it. Everything else is gone. So pi over 6 radians, that's 30 degrees. Okay. Any question on that one? All right. Let's just try one more and then we'll do the calculator one. Does anybody care which one we do? No? Let's do the top one. Okay, I know that's radians. How do I know? There's no label. Okay, where do we put radians to cancel out? Top or bottom? Bottom. Kobe, what number do we always think of with radians? Pi. You got pi, right? 180, that's with degrees. Okay, in fact, we got to get used to just not seeing it. Okay, pi's are gone. Anything else I want to reduce before I multiply? 2 into 180. And what am I left with for my final answer? 270. Good. 3 times 90. Okay, very simple problems as long as you know how to convert. All right, last one. Okay, so let's round this one off. If you're doing a problem and it's got a pi in it, usually they're going to ask you for an exact answer because the pi's are going to cancel out. This one doesn't have pi in it. It's going to be a messy answer. So round to 2 decimal places. Okay. Again, it's the same thing we've been doing. Trying to change radians to degrees. 180 in the top, pi in the bottom. All right, so let me do it out. I'm going to do it the right way using the pi button. Then I'll type in 3.14 and show you the difference. So we get 3 times 180. That's the top. Gives me 540. And divide by pi. Okay, you get 171.89. What's my label on that? Degrees. Do I need to put it?
Yes.
Yes, I do. If I leave it like that, that's 171.89 radians. Now it's degrees. Okay. If you use 3.14, here's what happens. 3 times 180 is 540. Divide by 3.14. I get 171.97. 89 and 97. Those aren't really that close. Okay, that's quite a bit off. All right, so on a multiple choice question, especially when you're trying to match it up, the book is always going to use the pi button, not 3.14. Okay. Any questions on that? Right, so tomorrow we'll see why or where changing degrees to radians or radians to degrees comes in handy. All right, so the homework, it's page 99, 36 to 68, just the evens. Okay, just do the evens.